Okay, so welcome to the first session. I have the honor to start the show. That's good. Today we're going to talk about the evolution of a MySQL database system. So from a single instance to a multi-region data recovery. So if you have an issue with the sound or everything, just interrupt me. But otherwise, I will just go to the flow. I just try to open the two windows next to me so I can see what's going on. Perfect. So the journey, I can call this session the journey to MySQL InnoDB ClusterSet, which is a new product, open source that has been released recently by MySQL. And this is the final goal, right? And so let's see how we can go there. So just some few words about me. So my name is Frédéric Descamps. So I am from Belgium and my native language is French. I am known in the MySQL community as LeFred, and this is also my Twitter nickname. So I'm a MySQL evangelist. I am working with MySQL since a very long time because I started with the version 3.21. And I like basketball, and I have a website where you can find a lot of information about MySQL, but not only, which is lefred.be. So it's a blog where you can find really a lot of information. So first, let's start what are the best practices in 2022, because related to the configuration, because this is always when I see people asking me questions over there, they have a system very, very old and with a lot of wrong assumption about MySQL. So let's have a small recap what we need to use in 2022 when we are using MySQL. Of course, our system must be one of the latest MySQL. So the latest version right now is 8.028. So if you say, oh, we are running 5.0.5.1 or something like that, it's very, very, very old, and it's time to migrate to 8.0. That you are using only InnoDB, so that you don't use, for example, MySQL, which is completely unsafe for your data. So you need to use InnoDB, which is the best transactional ACID compliant storage engine for MySQL. That you have the binary logs enabled. So if you want to do replication, if you want to do point-in-time recovery, and we're going to cover all that today, binary logs must be enabled. That the binary logs format should be raw, because in the old days the format was statement-based, so only the statement was sent in the or stored in the binary logs. Now all the data, the change, it's changed in the binary format, which is all the row that change. So this is the format you need to use, and that you are using GTIDs. So, and not position replication, but GTID replication. So every transaction have a global identifier. So this is also something we need to have. So let's start the evolution to HA in MySQL 8.0. And this is a small picture I made to explain where we are going and where we go. So at the beginning, in the most projects I've seen, people are starting with one MySQL instance. And to be honest, most of the time, the MySQL instance is also shared, is sharing the system resources with the application server. It's one application server, if it's a web application, with one database all on the same machine, and people start like that in their garage or startup, something like that. But when we do that, we should not forget that we only need to use InnoDB. If not, you will have really issues with your data, and that we need to keep the default durability settings. I've seen people using very poor hardware and disabling the durability settings to have something that, because if you have poor hardware, syncing all the data to make them durable has an impact. If you have good hardware, you don't see that impact. But if you have a very poor hardware, very slow disk, that has an impact. And then people are disabling this durability, meaning that if there is a crash, you may lose data. So this is something you should avoid, of course. So when you have one single instance, this is what all the risk, right? You don't have RTO, you don't have RPO, or very bad, and I will come back in those terms in one slide. And you can see you are not safe in case of a user making an issue, hardware issues, data center issues, stuff like that, network issues. You are not safe for anything when you are running on one single instance. Of course, if that single instance explodes, your data is gone and you have lost everything, right? So people start like that, and then they need to move up to go to the next level, because the data is it's becoming important, and losing completely the data might be an issue, right? And so this is where we need to define some objectives, and the RTO goes to hours and the RPO goes to 1 day. So what does that mean? The RTO is the recovery time objective. So how long does it take to recover the data? And the RPO, it's how much data can be lost. So we had nothing. So we say, okay, the next level is say, oh, if I have an issue, it can take me some days to go back live with my data, so that my database is again available for the application or for anything. And I can lose 1 day of data. So if I have the data of yesterday, I'm happy with that. So this is one possibility. So to reach that these goals, what people needs to implement, the DBA needs to implement, it's backups, physical or logical backups. We need to have a backup to be able to restore that backup. If you plan to use logical backups, please use MySQL shell and dump load utility. So if you're already familiar with MySQL, you may use MySQL dump, the old MySQL dump, to do your logical backups. This is obsolete now, and you should use something new called the dump and load utility from MySQL shell. So you can dump instances, you can dump schema in multiple threads, and compared to a MySQL dump, for example, you can dump in parallel and you can restore in parallel, which is much faster. So this is the way to create a very nice logical backups now. So when we have this one single instance with a daily backup, we are already safer for some of issues that could happen, and we have our RTO of hours and we have our RPO 1 day. Why do I say RTO of hours? Because if your machine crash and you have your backup, you need to rebuild the machine and restore the backups. If you have 2 terabytes of data, it will take some time to restore all that. But 1 day RPO, really? So we want to reduce that. We don't want to, if we have an issue, that to lose 1 day of data. We would like to reduce it to minutes at least, right? So how can we do that? So again, the objective is we can restore our system in some hours. We have that time, it's possible. But now we don't want to lose more than some minutes, because we might have an issue if we lose more data, because the data, it's always becoming important because our product is better, and then we say, okay, the application we are building, it's more and more attractive for people, more and more popular, and now if we lose data, all the users we have will be very upset with that, so we need to have this RPO 2 minutes. So to do that, the first thing we need to do is really to have durable bin locks. I explained earlier that we should keep the defaults for durability, and by default, the bin locks are durable. But I've seen a lot of systems that are disabling this durability. So to be able to play the binary logs, to replay them, to do this point-in-time recovery when the last backup, we will have to really ensure that the binary logs are synced at every transaction. So how we do that? So we have to have lock bin on, so meaning that the binary logs needs to be enabled, and the sync bin lock must be 1, right? These are the default in MySQL 8.0, not before, and of course we need to keep that. So when we have this enabled and we have a backup, if the machine doesn't crash completely, but if we have a problem from a user and we have access to the data, we have the RTO still some hours, but RPO now it's minutes, because if something happens, we can restore the backup of last night and replay all the binary logs. So how do we do that? This is the point-in-time recovery, right? So this is a technique that the administrator can restore and recover the data to a certain point in the past, right? So with MySQL, the point-in-time recovery just involves that you have a dump, and then you have the binary logs from the dump up to the point you want to restore, right? So, and we can use this point-in-time recovery to solve an issue. So somebody did something wrong or something happened, or perform a live migration. So if we want to migrate one data set to another machine or to another service, we with the point-in-time recovery, we can take a snapshot, a dump, a backup, we store it on the new machine, and then promote that machine as a replica and do point-in-time recovery to be able to go back at that time. So I will also explain this. So how does that work? So this is what we have in MySQL, right? When we do a backup. So we have here you can see we have the machine, the server is here, and then every day we are taking some backups, and the binary logs increase because we have every time we have some transaction that modifies data, we have binary logs that are created. We defined size. Usually it's 1 gigabyte, can be less, can be more. And we see that every day we take a backup and we have our binary logs here. So if we want to recover to that point, because between day 3 and so during day 3, somebody did something wrong. So how can we do that to restore up to there? We're gonna restore first the dump of the backup we did on day 3. So this backup we took here. So we're going to restore it on a new machine or on the same machine, depending what we have. And then we need to replay this binary log up to that point, right? So this is how we do point-in-time recovery. So I've seen a lot of people implementing this also, but there is some concept, very easy to understand, but sometimes that people forget about it or we're not expecting it like that. So usually when we make a backup, and of course when we verify that backup, the binary logs that we have on the system are purged because this takes a lot of disk space, right? And so to save disk space, people, when they do their backup, they remove the binary logs before the backup. And so this is what's happening. So every day we take the backup, we check if the backup is correct, and then the binary logs here are purged. Then on day 2, we take a backup, and these binary logs are purged, and so on. So last backup, now it's on day 4. The only binary log we have on our system, it's the one of the current day, right? So meaning that all the recovery points are day 1, the time we took the backup, day 2, at the time we took the backup, day 3, at the time we took the backup, day 4, at the time we take the backup, and all points here from that backup that are still in the binary logs, right? So this is very important to understand that if you want to restore here, it's much more different, right? So my data is very important, and I have a heavy workload now. So I would like to lose less than a second in case of a problem. So minutes, it's still too much of a loss. We want to reduce that. So how can we do that? So we're going to change this RTOs. Always we have some hours to restore in case of an issue, but we want to have RPO less than a second, right? So the first thing we can do that is to start by improving the point-in-time recovery process we have created. So to do that, we're going to enable GTID, right? And we're going to save in real time the binary logs to a different system, to be sure. So, and we will be more safe also in case of the machine where the binary log and the MySQL instance it's running. If it crashed completely, we have this binary log somewhere else, and we don't lose too much of a time, right? So here is just a schema. If you want to implement that, for example, in the cloud in OCI, you can stream the binary logs in object storage. But this is just an example, right? the technique is the same. So first, you need to enable GTIDs because GTIDs are not enabled by default. If you can afford a restart of the MySQL system, you can see that GTID mode is off. You just do set persist only, GTID mode equal on. Then set persist only and force GTID consistency equal on, and you restart. Next, when it's restarted, GTID are enabled, and all modification will have their own identifier, all transactions. If you cannot afford a restart, it's possible in MySQL to also enable GTID, but it takes just a bit more of commands. So the first thing is to do set the persistent for GTID consistency to on, so like we did here. But then we need to move the GTID mode from off to off permissive, then from off permissive to on permissive, and to on permissive to on. We need to pass to all these steps because if there is some traffic happening at that moment and there is maybe some replication also involved, we don't need to break everything. So we need to pass by this mode to make it possible, right? And when it's done, you can see that GTID mode is on already. So this was just a parenthesis on how to create that easily. And now, so we have our GTID. So all the modification have an identifier, much easier to when we need to find where we need to go, what we need to restore. And then we need to save the bin log somewhere else. So to do that, we're gonna create a dedicated user. Don't always use root for everything. So it's much better to have a dedicated user. So in this case, we have this user that I call getBinLog. It has a password. It requires SSL, so the communication between where we store the data and this client and MySQL, it's all encrypted. And we give only this replication privilege for all the table and schema to that user. So on another system, so where the system that will stream all the binary logs, we're going to use the command that it's always provided with MySQL that is called MySQL binlog. So MySQL binlog, it's used to decode the binary logs when we are looking for some information, but it's also used to read live binary logs and to have the possibility to also stream them directly. So this is what we use here. So read a row, read from the remote server, never stop, the remote server host name, the port, the user recreated, the password, the SSL mode, and the name of the files we want to start from. And this is how we are able to stream all the binary logs. So as you have noticed before, I was explaining that when we can recover, if we purge these binary logs, and for example, in OCI, they are purged every hour, we need to, and we relocate these binary logs to be able to replay them, right? So there in the cloud or in the NAS or whatever, wherever you want, you can store all these binary logs. And this is what you need to do to be able to play them and to create this point-in-time recovery for any time you want. So if we have the binary log streamed somewhere else, so here, as you can see, I have all the binary logs since the start of the server. I can recover at any time. If I say, oh, I want to recover here, I need to restore these two backups and then replay this bin log that I can get from here, right? So with one single MySQL instance, if we have daily backups and external bin log archiving, we are much safer already to many of these points. I always put here red and green because, for example, if the rack completely breaks and you store the binary logs on another server on the same rack, of course, this won't help you that much, right? So hours, and here we can recover to server to up to 1 second, right? So now we move again to another level, right? Because the service, it's very, very important. And I would like that my database also gets available within minutes and not hours to rebuild everything in case of an incident, right? So I want to reduce this RTO time from hours to minutes. So if I have an issue, I want my service to be back in minutes. And of course, I want to keep my RPO less than a second, right? So how can we do that? So the first solution we have is to use MySQL InnoDB ReplicaSet. So everything I'm discussing here, it's completely open source, right? And so you can download it, you get it with MySQL, and there is nothing special, right? So it's based on the well-known asynchronous replication, but it's easier, much easier, and easier is always better, I say. So you should use this instead of trying to make replication by yourself. The data provisioning, it's included with the clone that it's part of MySQL 8, so I will also show you that. And you can use 2 or more nodes. It has a manual failover, and it has also transparent automatic query routing with MySQL router. So the architecture looks like this. So if you have more than one application server, most of the time the application server have a very light MySQL router in it. So they connect locally on the router, and the router will send the traffic to the MySQL that is the replication primary node. So in this case, you can see that this one is the primary, and it replicates the data here, right? And MySQL shell, it's a terminal client from MySQL that allows you to orchestrate all that with very simple commands that are part of the admin API. And these commands are in JavaScript or in Python. So this is, I will show you in JavaScript, for example. This is how you do to do that. So we have the actual server that is running. So we connect to it and we do configure ReplicaSet instance. So it checks if bin logs are enabled. It checks if GTIDs are enabled. If everything is okay, it won't complain and say it's okay, I'm done. And then you just do DBA create ReplicaSet and you give a name to your ReplicaSet. And that's it. Your server now, it's part of a ReplicaSet that you have created, right? And on the second server you want to use now, so in case of your primary as an issue, you want to promote the other one as primary, what you need to do, so you do the same configuration. So this is just a new server where we have installed MySQL, nothing else. There is no data, there is nothing, just MySQL. So we do DBA configure ReplicaSet instance. It checks the configuration. It will enable GTID because by default they are not. And after that, you say, oh, I want, so you can see here, I use rs variable, which I defined here, which is the name of my ReplicaSet, and I do add instance, and I give, for example, the name of my second server, and it will provision all the data to it directly, and it will be part of the replica directly. It will work, so you can see here. So I do configure ReplicaSet instance. So this is an example for the MySQL 2. It says, okay, you have only root because there is nothing yet on the system, right? It's better that you create an account to administrate all this, the cluster set, so the ReplicaSet. So you say, yes, I want to create an account to administrate everything. So I call the account cluster admin. I put the password, and then it says, oh, and for GTID consistency, it's off. You need to put it at on. GTID mode, it's off. You need to put it at on. Server ID, it's 1. It's the default. It's better to have a very unique value. So let me generate a unique one for you. So you say yes. Then it says, do you want me to make the change? Yes. Do you want me to restart the instance? Yes. And it's done, right? And after that, you do, okay, please add to the instance. And it does, okay, there is no data to it. The other has more data. Should I transfer all the data to the new server? You say, yes, I want to use clone to do that. And it will copy copy, transfer all the data very quickly to the other machine, and it will be part of the replica set. And you can see it now. This output here, this terminal, it's MySQL shell. So in MySQL shell, you do array status, and it says, oh, this is a replica set. The status is available, and this is the topology. We have two systems, right? And this one, it's as the primary role. This one as the secondary role, and this one is read-write. This one is read-only, and everything it's fine. And this is asynchronous replication. Now, for the router, to configure the router, we just do MySQL router bootstrap. We give the IP of one of the nodes, and that's it. It will configure completely everything for you, and you can run it. And from the shell, you can also list all the routers that are part of the replica set, because as I said, it's very common to put the router on the application server. So if you have 10 application server, you will see here 10 routers and when they were checked and what they are doing, right? And so for the manual failover, like I said, here it's manual, meaning that if there is an issue with the primary crash, for example, the operator we will need to have a pager alert and needs to say, oh, there was an issue. I want now to promote my secondary as primary, and it has to do a failover, right? So we do the manual. So we do a force primary instance, and we provide the other one to force the secondary to be promoted as primary. So we do this replica set force primary instance, and we do the failover, and the application will connect to the other one completely manually. So this is where it is minutes, because you need to do this manual stuff. Manual, it's necessary because we have only 2 instances. So there is no part in this asynchronous application. There is no quorum and stuff like that. So it needs to be manual because we are using asynchronous replication. So this is how we do it. And as you can see, with this system, with the replica set, we have this RTO now lower 2 minutes, and RPO always less than a second. Now, the inconvenience here is that you need to have an operator that will be paged in the middle of the night if there is an issue, and he needs to fix it, right? So now my service became so important, and I don't want to disturb my operators during the night. I would like to be almost always up, to have automatic data, automatic failover, and never lose data. I don't want to lose any data at all, right? So I want to have RTO to seconds now, and lower the RPO to 0, right? So how can we do that? So we need to use MySQL InnoDB cluster. So it's not ReplicaSet, but it's cluster now. So it's based not anymore on asynchronous replication, but on group replication, but easier. And as I said, easier is always better. The data provisioning is also included, but now we need to have 3 or more nodes, but the odd amount of nodes, to have this quorum facilities to work, right? It has automatic failover. It also uses MySQL router, and you have different consistency level that you can configure if you want. So this is how it looks like. So now you can see here, it's almost exactly the same, but we don't use asynchronous replication. We use group replication now here. It's a different type of replication, right? And we need to have at least 3 nodes to have this automatic failover. You can use group replication with 2 nodes, but you won't have automatic failover, because if you have a network partitioning, no one can decide what's going on, right? So on the replica set we had earlier, we will just drop the metadata schema, and instead now we're going to create a cluster. So we do DBA create cluster, and we call it my cluster. On the secondary node that we had already, we just do stop replica, reset all replica information to clean it up, and we just do add the instance in the cluster, and that's it. And finally, we start a new machine again. We do configure instance. We do we check we attribute here the variable cluster. We get it, so we do get cluster, because here, for example, when I create it, I defined this variable. But if I'm in another session, I can always define this variable and get the information from get cluster like this. So then I add the new instance called MySQL 3, and that's it. So now we have 3 nodes with the same data completely working all together in the InnoDB cluster. And of course, I just need to bootstrap again the router for InnoDB cluster, because it was configured for the ReplicaSet. So I just here do a bootstrap again with the force to force the modification of the configuration. Then I restart the router and it works. So it was, as you can see it's very easy. And again, I can see all the status here of my cluster, all my 3 nodes running all together, and by default, one is primary. Depending of your workload, you could write on all of them if you want. There is an option to do that, so you can write on all nodes at the same time. So now with InnoDB cluster, we can see here that we have the RTO to seconds and RPO to 0, so we don't lose data. So we are very happy. But as you can see here, if there is network issues or if we have a very big problem in our data center, we might not be safe, right? So if something happened to our data center, what can we do? How can we deploy a disaster solution, right? The answer is MySQL InnoDB ClusterSet this time. This is the ultimate evolution. It's available since MySQL 8.27, and it has fencing support since 8.28, which is the latest version of MySQL. And this ClusterSet, it's the result of several transformations that the MySQL engineering team has done in the previous release. Like now you know that we have automatic connection failover for asynchronous application, but also for group application, and many changes that we have done recently. Our goal was to create this ClusterSet. So this is how it looks like, ClusterSet. As you can see, we have now multiple clusters on different data center. It can be many if you want, and they are all linked together by asynchronous replication. Because why asynchronous replication here and not group replication? Just because group replication can be, it's fragile to the network. If you have a large latency, it can be problematic for performance. Asynchronous replication doesn't care about that. It's less sensible to network glitches and stuff like that. So between the two clusters, we use asynchronous replication. And as I said, we can deploy more complex architecture like this. It is completely possible. And then you say, okay, this is my primary cluster, this is my secondary. Now I want to promote this one. All this is possible. So with ClusterSet, as you can see, RTO is a second, RPO is 0, but we are much more safe to many issues that could happen. Just some extra, since MySQL 8.19, if you don't want to use the router, you can use DNS SRV if you have a discovery service like a console that it's already working on your system. It is possible to do it like this without any issue. The MySQL shell that I show you, all the GUI, it's also now included in Visual Studio Code with the MySQL shell plugin for VS Code. And you can all do this also directly, use the admin API directly from VS Code, right? In case you want to also try MySQL E12, you may have heard about it. So this is some analytics and very fast queries possible in OCI. You can have a free stuff here. So show your love to MySQL. using the hashtag MySQL. And if you want to discuss with me and the engineers, we are also on Slack. You can find us there. So this ends my session, and I will check all the questions if you have questions for me.
Thank you so much, LaFred, for that. We really appreciate you coming and sharing your knowledge at LinuxFest. Yeah, at this time, if anybody have questions, please post it into the chat. Reminder that the audio and video are still being recorded at the time, but we'll wait a little bit for the questions to start rolling in.
Sure.
And Fred, you see the public chat all good?
Yes.
Perfect.
So don't hesitate, and if you have questions just even related to MySQL, it's fine for me, no problem.
And the final announcement is that when we are done with this, you guys are all welcome to join us in the Wonder Room. It's a virtual hangout so that there's more discussion or topics. And I will post the link to the Wonder Room in the public chat now. But if you have any questions or just want to hang out with them, I don't know, LaFred, are you going to be at the Wonder Room for a little bit?
Yes, no problem.
Perfect. I guess that's it. There's no questions so far. So, LaFred, thank you again for sharing.
You're welcome. Thank you very much for having me.
Anytime.
Bye-bye.
Recording will be stopping now.